Welcome back, friends. Let's continue with class 12 mathematics chapter 3 matrix. Today what we will do is, in the previous videos we have already seen how do we add and subtract matrices and how do we multiply a matrix by a scalar. So today let us learn how do we multiply matrices. Now, regarding addition and subtraction of matrices, the only condition that was required was they have to be of the same order. They have to be comparable matrices. Then only we can add or subtract. But it is not the case for a matrix multiplication, because it states for any two given matrices A and B, we say that the product AB will exist only when the number of columns in the first matrix equals the number of rows in the second matrix. That is, when AB exists, we may say that A is conformable to B for multiplication, but that may not be the same for B to A, because as per the statement, it states the number of columns in the first matrix should be equal to the number of rows in the second matrix. Similarly, number of columns in the matrix B should be equal to number of rows in the matrix A. Then only BA also will be possible. Let's try to take an example and solve. That is, I've given you two matrices here, A and matrix B. We are supposed to told to find A. So now let's try to solve here. A is, now we have here 3 rows and 2 columns. So A is a 3 by 2 matrix, and B is we have here 2 rows, 2 columns, 2 by 2 matrix. So then A is a 3 by 2 matrix, B is a 2 by 2 matrix. We want to check whether B is possible or not. So for that, we have to see to it that the number of columns in this first matrix should be equal to the number of rows in the second matrix. So we can clearly see that they are equal. So what will be the order of the new matrix that we should have? It is going to be of the order 3 by 2. That's how simple it is for matrix multiplication. So in that case, of course I forgot to tell you about that. So that's how we will be getting the I haven't given you the definition of the theorems based on this, but here I just want to focus on how to multiply and get solutions done. So then in that case, clearly the number of columns in matrix A equals the number of rows in B. Therefore AB exists and it is a 3 by 2 matrix. I repeat again, since number of columns in the first matrix equal to number of rows, AB will exist and the order will be the two extreme orders, that is 3 by 2. Number of rows will be 3, number of columns will be 2. So now when we go for multiplication, that is A into B, so that will be 2 minus 1, 3, 4, 1, 5 into B, minus 1, 3, 2, 1. Now since this is really going to help the students, since we know that our matrix will be of an order 3 by 2, in order to avoid any confusion, let's try to construct this 3 by 2 matrix, that is 3 rows and 2 columns. That is 1, 2, 3 rows and 2 columns. So that will be A11, A12, A21, A22, A31, A33. So this will be a matrix of order 3 by 2. And when you do this rough sketch of the resultant matrix, it is really going to help you in multiplying matrices. And how? It is like this. Since we know that our new matrix will be of this order 3 by 2, the first element will be A11. That means, in other words, A11 means you will multiply the first row and you will multiply and add the corresponding elements of the first row with the first column. First row with the first column, you will multiply the corresponding elements, that is 2 into minus 1 plus corresponding elements minus 1 into 2. Similarly, the next element A1 2, that is, you will multiply the and add the corresponding elements of the first row to the second column, that is 2 into 3 plus minus 1 into 1. Continuing, A21 represents you will multiply and add the corresponding elements of the second row to the first column, second row to the first column, 3 into minus 1 plus multiply and add the corresponding elements, 4 into 2. Continuing, A22 second row second column, second row second column, 3 into 3 plus 4 into 1. Continuing, A31 third row first column, corresponding elements, third row first column, so 1 into minus 1 plus 5 into 2, last one, third row second column, third row second column, third row second column, 1 into 3 plus 5 into 1. So there is no need to be confused, because if you have this sketch of the resultant matrix, it will always help you avoid the confusion, because you will stick to this, like A11 represents you will multiply and add the corresponding elements of the first row with the first column, so that will always help you avoiding confusion. So minus 2 minus 2 minus 3 plus 8 minus 1 plus 10, 6 minus 1, 9 plus 4, 3 plus 5. So our resultant matrix will be minus 4, 5, 5, 13, 9, 8. So this is our resultant matrix. So likewise, let us continue with exercise 3.2 based on multiplication. That is question number, let's try 3, that is compute the indicated products. The first one, AB minus BA into A minus BA. So here the matrix are of order, first one is of 2 by 2, second order is also 2 by 2. So now we have to go in this direction, multiplication. So then in that case, like number of columns first matrix, number of rows first matrix, second matrix. So our resultant order will be matrix of order 2 by 2. So let's draw the sketch. A2 1 2 2. So that will be first row first column, first row first column, add the corresponding elements, A into A square, B into B square. Next, first row second column, first row second column, A into minus B, minus AB plus B into A, that is again AB. Continuing with the second element, A21 second row first column, second row first column, minus AB plus AB. We will multiply and add the corresponding elements. I repeat again. Next, second row second column, second row second column, minus B into minus B plus B square, A into A plus A square, because minus into minus will be plus, so we have plus B square. So our resultant will be A square plus B square, 0 0, A square plus B square. Let's try question number 2. 1 2 3 2 3 4. So here our matrix, the first matrix is of order 3 rows 1 column, second matrix is of order 1 row 3 columns. So number of columns, and we move in this direction. So number of columns is equal to number of columns is equal to number of rows. So our resultant matrix will be a 3 by 3 matrix, that is a 1 1 1 2 1 3 2 1 2 2 2 3 3 1 3 2 3, 3. So let's start. A11, that is first row, first column. So this kind of matrices, matrix multiplication becomes slightly confusing, so that's why it's always good to have this kind of sketch, so all the confusions will be gone. So first row, first column, first row, first column, so we'll just multiply 1 into 2. Next, first row, second column, first row, second column, 1 into 3. Here we don't have any other elements to add, that's why first row, because this is a column matrix, this is a row matrix. First row, third column, 1 into 4. Continuing, second row, first column, 2 into 2. Second row, second column, 2 into 3. Second row, third column, 2 into 4. Next, third row, second column, third row, first column. Next, third row, second column. Next, third row, third column. So that will be 2, 3, 4, 4, 6, 8, 6, 9, 12. So this is our resultant matrix of order 3 by 3. So I believe that this video has been helpful for you, because this is one of the most important topics in matrices, that is matrix multiplication, where generally students, I find them getting confused a lot. So I've given you some hints on how to multiply matrices and some hints which will help you make your problems matrix multiplication easier. If you have liked this video, do tune in. In the next video, I will do some more questions from exercise 3.2. Thank you.